Hello class, we're going to do lesson number 8 and I'm just going to give you some really good news. I'm just going to cover lesson number 8. You're not going to have to do the homework here, okay? Because really this is just reinforcing everything you've already learned. If you want to do the homework and get even better, that's good, but let's just understand that we do have complex fractions that we're dealing with sometimes. And if we look at this fraction here of 29 plus 1 over 2 plus 1/3. Okay, I mean, does it get much more complicated than that? Okay, now we're looking at this complex fraction, and a complex fraction, if we read on page 545, is a fraction that has one or more fractions in its numerator or denominator. Okay, now every complex fraction can be written in a simpler form. It's just really about simplifying it, getting to the point where you can now do something to solve or to express it in a simpler fashion. Because when we're looking at 29, okay, what do we have? 29. I can understand what 29 is. Okay, if I had $29 in my pocket, I'd understand that. But what is this 1 over 2 plus 1/3? Well, it's 2.33, so it's quite not, it's not a half, it's a little less than a half, it's not quite a third. And again, just trying to really understand this, but if it were just numbers, it wouldn't be a problem because we could figure that out. But imagine when we start putting algebra into this and we put x's in there and variables and y's. Well, let's just understand that we can write them in a simpler form. Okay, so how we would do this is by taking this particular part right here and just say 29, and we're going to write this as 1 over 7/3. Could we not? Yes, we could, because we know that this is 3/3. I'm sorry, 6/3. 2 is equal to 6/3 plus 1/3. So all we did was we we added 2 and 1/3 and we expressed it as a fraction. So now we just simply have 1 over 7/3. Now, so we can now now it says here, so the Huygens used in designing his model, that's this individual. He was a scientist. I didn't go into all the complexity of this. I just kind of wanted to show you more of the fraction. But the number is 29 plus 1 over 2 plus 1/3 can be written as 29 and 3/7. So you might say, how do we get that? Well, remember that we're going to be able to take, let me just probably write this as 1 over 1, right? This is 1 over 1, and that's being divided by 7 over 3. And we learn that when you divide 1 over 1, you divide 1 over 1 by 7/3, it's the same as doing the reciprocal. So all I would do is express this as 1 over 1 times 3 over 7, which means that this is equal to 3/7. Okay, so we converted this to 3/7, and it's 29 plus 3/7, so it's 29 and 3/7. Now we can turn this into just one big fraction and multiply 7 times 29 and add 3, and that would give us 206 over 7. Now, so we will refer to the fraction such as 206 over 7 as a simple fraction. A simple fraction is a fraction that does not have fractions in its numerator or denominator. So we took this 29 plus 1 over 2 plus 1/3 and turned it into 206 over 7, a simple fraction. Every complex fraction can be transformed into a simple fraction, although it was helpful for this Christian Huygens to write numbers in forms such as 29 plus 1 over 2 plus 1/3 in planning his model of the solar system. But simple fractions are usually preferred. So we have some examples here where they simply did the same thing. It's a matter of just taking step by step everything that you've learned and just applying it. So the complexity is there. Simplify it. Okay. Now you don't have to do the homework in this particular section, but it's that you know that you can take something very complex and simply crunch it down into something simpler. And that is really just the end of this chapter, this lesson, and this chapter.